GitLab.
Yeah,
Okay.
so I wanted to basically, I think one of the main topics that I think some people have, and I think you highlight this was dependency injection. It's like a little bit of lack of knowledge on that. And I
Mm-hmm.
specifically, Shinya created an MR that I think would be good to like look over because I think this how we're kind of combining services for
Mm-hmm.
internal tracking seems like a good, you know,
Yeah.
review, even though it's not fully finished. I was thinking like, okay, we could take a look, see exactly how we currently do internal tracking for sending our snowplow events, and then how do we inject the client within the
Mm-hmm.
service and kind of go over that. And I think dependency injection, just as a overview, Python is this is the library we're using for dependency injection.
Mm-hmm.
And I think one of the things, and this is another kind of little side tangent, is kind of like how we're creating these factory objects and then
Yeah.
injecting them at
Yeah.
runtime, like whether it's like a chat Anthropic factory or a light LLM factory. And that is a little
Mm-hmm.
bit, I guess,
Yeah.
confusing. So
Would
I
you
guess,
like for an explanation how, well, we can start with this. I can see there's a lot of there, but we can I can go a little bit over how dependency injection works in AI gateway first,
yeah,
and then we can move to the MAR.
yeah, I think that sounds like a good plan to me.
So let me open SkyDraw. Okay, so let me share my screen quickly. Uh, so what it does, dependency injection, is when you're building an application, um, grown. So this is your app. It's gonna have a database. It's gonna have I don't know, some API, um, some instrumentation that all needs to be initialized, right?
Hmm.
So wait. So what happens is with suppose that you have multiple applications, so you have to test this application, and when you have to you have to test the application or you have to create multiple versions of the same application, how do you change these dependencies? How do you set up these dependencies depending on context?
Hmm.
So that's what dependency injection is there for. The idea is, wait, what is, okay. The idea is that instead of having this being part of a of your app, this is injected from the outside into your application. So if you have your application stays the same and it behaves, you create an interface over what a database would look like, or instrumentation would work like, or an API would work like, so that your application can stay the same and you can create like another exact same application, but with a different implementation of this API, right? So a different implementation of this instrumentation. For example, mock. Mock is a good example of this. This is very, very useful when your language does not support patching. So languages like Java, they do not support you to patch code, hot like live code, like we usually do with Python testing, right? So that's one of the bigger benefits, practical benefits. There's the benefit of structure, and there's the benefit of like decoupling. So how do we do this in AI Gateway? Um, we let's go over. I'm on the completions. The completion is a good example. So you can see here that a lot of do on the setup of a completions, we have a lot of things being injected. So it depends. So the completions legacy factory depends. It's injected through this method. The that is that is defined here. Get
Yeah.
code suggestions, and then it gets the container application. Container application is a group. of it sets up is a group like this. And it can be built of smaller groups. So you can have a group that says different models, different instrumentation. So this is a container here. This is your app. And this is your container.
I guess
Container.
for
So
how
hmm,
we how we create these subgroups, is there like a specific general
yeah.
guided practice? Like, because if we go into that container application, let's say code
So this
suggestion.
one. Yeah.
Yeah.
So this is container, provider, and return the container. Uh, so let's see there. Get container application. There is a different place where this is initialized. Okay, so there's no sometimes like I think on models you have a specific container here. On models you have a container for all of the potential models that are
Hmm.
in this. But you also have, let me find where another container. So the prompt registry I also have a provider here. So this is containers. So whenever you search for, you can search for this one. Containers,
Hmm.
you're gonna find all of the potential containers that we have on the app. So if you go over here, let's go over to the let's go over the prompt container. So whenever I need a prompt registry, I can use like whenever I required prompt registry using that depends format, it will fetch this one.
And for this
Uh,
example, we're creating a single prompt
yeah,
register.
you create you create like it's a scoped singleton for that specific container, so you can have multiple containers with different singletons. So it brings some advantages.
Mhm.
Now, and then it creates over this, and then you can use that. Now I have some. I'm not entirely sure that we need dependency injection on AI gateway. This is something that I'm thinking that we could potentially remove from because the downside. Let's go about the downside of dependency injection. The code becomes much harder to read. It's really hard to find where things are defined and how things are created and how where things are set up. Like for example, where is the Light LLM client being run? So I go over completions over here. Where's completions, code completions. And then there's completions legacy factor. Okay, but there's a light lamp factor. And then I go here, and then I have to go here. There are three different that I don't know which exactly is, but then so this is completions. So it should be completion. This is generation. So here it's generated. So now, okay, now light and lamp factory is a code generations class. So this is the class that we have for this. Um, I'm not entirely sure what this does, but light LLM chat is actually another property that is injected here, that is created here. Look,
Mm.
there's another one that is created. So it creates a new instance of this model. Um, or it's passed on. So it becomes a net of things that it become really hard to pinpoint what is depending on what and where where do I need to change something? Becomes difficult to read. Recently I implemented a change that was the model config. Um, model what is the class?
Like
It's
config/model.
I think it's is it models? No, it's not over here. Model. I think there's something. Okay, model selection config. So this is also a singleton. So it's an eager, it's a lazily load singleton that I fetch that is created when the first time is fetched. But I used a different pattern. Instead of using the dependency injection, I used a different way of setting up singletons uh, on on Python. So this tells that when I call the create class, and if there is already an instance, it will return the instance, otherwise it will return a new instance and it won't return a new one. So instead of going through the whole process of dependency injection, I can simply, when I use this, where did I use it? I can use this way, right? So I know which class was created. I know for simple configuration, simple setup, this is a different approach that can be taken.
Mhm.
And it becomes a little bit more readable.
Yeah, for the code
Um,
suggestions approach, I guess since they have a different container and like what they're trying to inject potentially like five different or six different classes at runtime of a different
mhm.
model provider. Is that maybe why, I guess, it is difficult to search which which they were actually factory or object we're creating, whether it's LiteLM chat and Amazon Q model. But I guess with the initializer, if we tried to refactor it that way, how do we know that it needs to be a type of a specific class of
So, well, all of them will return, I think, the same type. Uh, Tropic Cloud. This returns a cogenerations. This returns a cogenerations. Ideally, all of them, like if they're used interchangeably, they would need to be, but they are not because of this Tropic factory. That's the only one that changes from all of the others. Luckily, we are moving away from that one, so that's nice.
Hmm.
Um, because in theory, they should behave the same way. Um,
They should all be a code generations
they
object.
should all be a cogeneration. So if I go back to completions, this one. So now I have all of these factories. And then here along the code, for example, where's the function that it's passed? So this is here. Build code completion, then I have to pass on all of these factories. And on code completions, then I decide that when the code decides uh, which one is the right factory to be used. So it's very convoluted. It makes it difficult to pinpoint on where that is.
Hmm.
That being said, what this helps with is that if completions agent factory, for example, is not used, then the classes needed are not even imported. Like they're not part of the code base because it was never like the factory is lazily loaded and it will just load the file when it's being called. So there's no like circle dependencies or avoids a lot of circle dependencies because of that. So if the code is not used, then the libraries are not used. So that also helps, but that's not a benefit. Cool.
Great. So that is, thank you for that overview of dependency injection. I think, I don't know if this is necessarily a great MR to look at for dependency injection because I do think it is just a value, like creating a new library for an internal event client. But I know we do inject um, as a class this snowplow internal event client. So this may be not the best MR, but I thought, oh, well, it's touching two services and we're trying to
Mm-hmm.
make a joint library that is
Mm-hmm.
shared. And, whether you're talking with AI gateway port or the dual workflow service port, you should still have the same client class.
Yeah.
And I think
Mm-hmm.
that's where this is like, okay, it uses this tag add inject, and then there's a container application. Maybe I should just check out this branch. You know, we can go from there. But instead of scrolling
Mm-hmm.
along this, let me stop and do that really quickly. Mm. Okay. Yeah. Great. Now, I normally like to use what got changed here. I know I can use the GitLab workflow to see changes in a file. Nope. Uh,
Is that the merge request you're reviewing, maybe? Were you
yeah,
assigned as reviewer to that one? So it's the fourth item over here on
fine.
merge request. Yeah.
I'm not reviewing it, but
Okay.
uh, here we go. I say that these changes, maybe I can get all of them added to. Um,
I think if yeah, that one.
let's see, is there a way to show all the changes in like a view format? Uh,
Maybe over the Git. Is this your current branch?
I'm
Your
currently, yes.
so on the maybe on the Git symbol over there on the left side, the third from top down, or over there,
Yeah,
I mean.
sorry.
Changes.
No, no, it's somewhere here. Show changes. Yeah, let's go.
There's
Yeah, is it tree?
I don't know.
Um,
All right.
let's go back to the MR. It's a
Yeah.
little easier. Um, I think we can maybe show all changes here. Uh, anyways, uh, here's an example where they're initializing this tool executor, and
Mm-hmm.
we're passing in the internal event client. And then it says provide internal event, this container act application. So if we looked at here, we should see an internal event container in somewhere here. Internal events should have a container.
I think you're sharing your VS Code.
Okay. Yeah. Now,
Yeah.
okay.
Yeah.
So the AI gateway
Mm-hmm.
container application, internal events, it should have, yeah, here we go, this container class. Um, and effectively, instead of pointing directly at the AI gateway service, it looks like it's creating a separate library, which
Mm-hmm.
have an internal event client. And the, I guess to determine that what is a container, it's a pretty simple one here. It looks like it's takes a config that's required, and then has the client class here as a singleton, which is this internal events client
Mm-hmm.
class, and then with some, you know, uh, attributes enabled, like config enabled, batch size, and this. And I guess where those, and this is just to trace like this whole code to get an understanding if I was reviewing it, is these configs are coming from our, if I remove it, these uh, batch size
Mm-hmm.
configurations. And I
Yeah.
guess the
Mm.
question now, if I was reviewing this, is how exactly do these get loaded into the configuration file?
This is a library that we used. It's the if you look, so let me find it. At least on AI Gateway, you're gonna have where is AI Gateway? Let me find the entry point here. Init app.py. So okay, yeah. Uh, this is the load .env file. So let me quickly share my screen here. So how do the config get loaded? So here on AI Gateway config, you would have this config that has all of those configurations over there. So instrumentator, um, internal event, Google Cloud Platform, and this says that this object internal event is actually this one that has these values. How does it maps then? So if I go to my env example.env and I look for internal event. So the first one is the service. The second one is that property. And over here is this is the prefix, the property, and the group, and the final property. So this would, let me see if I also have this on, um, the, 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 okay, this AI gateway. So this means internal event will get mapped uh, here. So this is internal event, and then I go to example.env. All right, yeah. So internal event is this part, and then enable, then I go to this class, and then enabled is this one. App ID you see over here as well, and endpoint you see over there, right? So there's the mapping.
Is there a specific reason why there's a double underscore in the naming convention?
It's how it automatically loads the things. So it allows for one only. It just means that it's this thing over here. Okay, let me go over here. So one underscore means an underscore from here. Double underscore, it means that it will be the part of that group. The first one, this one is just the prefix, so that we load all of this from the .env. So this just
Yeah.
loads also if nested delimiter is over here, and then the prefix is over here, and then find.env is over here, and then it's gonna load all of this. So when you go into the app and you call config, it's gonna pull all of that configuration. This could be
Great.
a singleton that is made available to all files, but here we use the get config, for example. This is the singleton that does that. Um, it can also be used with dependency injection, but this way, when we use tests, we can also pass on specific values for each configuration here in the model. So that's how the config works.
Gotcha. Okay, that resolves a little bit of why I guess I didn't see that double underscore nested uh class, and that
Hmm.
that that solves a little bit why exactly we're doing this convention and how it
Yeah,
gets automatically mapped. Okay,
yeah. We're mapping like line by line to an object based, but then to define each object, use the double underscore as a mapping.
great. Yeah, I don't know if the MR does that much of actual dependency injection, but from just reviewing that small bit, it seems like we're taking both of our services, internal events into a shared library and then
Hmm.
figuring it at a container level of like it needs to take an internal event client and then create that client class, and you're still calling the um, same
Hmm.
methods. Nothing's changed about the actual implementation of the
Yeah.
client. But that was something I was like thinking maybe there'd be a little bit more, but that makes sense.
It's This is very useful. Like dependency injection can be very useful when how can I think of an example? So we have a lot of models, and we don't want to import all of them, right? So we use that LLM, but in theory, like our application does not need to know about what specific model is being used. It just needs to know that a model is going to be called. So a model is going to be injected in there, and you separate that concern. So that's when dependency injection is most useful. Um, I find it better for statically typed languages like Java, where you know exactly the class that was created. You can trace. It makes it easier to find. And in Python, I found it really difficult to read the code once dependence, like when it's just one, two, or three, or it's just like one layer of dependency injection, it's not a problem too much of a problem. But if it goes deeper than that, you have multiple containers, and some places containers are used, or some places containers are not used. So and we don't use, like, even if we have dependency injection, we don't use the right way. An example, our whole app, we have two main configurations: self-hosted with custom models enabled, and SaaS with custom models disabled. Ideally, what would happen is I would have a container for those self-hosted and a container for .com configurations. When I load in self-hosted mode, I would just pass that specific container for self-hosted. All configurations would be ready. We don't do that. What we do, we have if else's over custom models enabled everywhere in the code base either way, because that's easier on a
Mhm.
point solution, like where you're trying to fix it right away. We try to go a little bit. At some point, I tried to help to move to a container approach, but it was a bit overwhelming to do the refactor. But
To get
so even
all
if we do, you have dependency injection, we don't use it on the proper like. We are currently at the worst of both worlds, I believe.
Yeah, I used dependency injection with Java with the Spring framework, and it seemed easier
Hmm.
in the sense that you have like, and I don't know if we use this pattern, and it's really much in Python, but like a builder object where you're
Yeah,
building, whatever object in your container that then you inject in the class the required dependencies, like, models, let's say example, like
yeah,
a application. It doesn't seem that easy to figure out and trace back here in
yeah,
this Python like structure. I don't know why exactly. Is it just
yeah. It's the lack of typing. The lack of typing makes it difficult to read or strong typing. And right, I gotta go.
awesome?
But it was good talking about code. Have a
Yeah.
good one.
Yeah, thanks.
Bye.
Catch you later, Marv. Bye.